In this video, we're going to focus on covalent bonding and everything what you need to cover in covalent bonding based on your IB, IGCSE and O-levels chemistry. So let's start. Covalent bond is the force of attraction between the shared pair of electrons and the positive nuclei of the two atoms. So one covalent bond comprises of two electrons. Let's take an example here. Let's take an example like we have a covalent bond between the two atoms of hydrogen. So imagine we have one hydrogen atom and hydrogen is containing one electron. So I'm going to draw its structure like this: hydrogen with one electron in the outermost shell like this. Okay, so it needs to stabilize its structure and it will be sharing electron with the neighboring hydrogen atom. Let's say if we have a hydrogen molecule, so it is comprising of two hydrogen atoms. So we have another hydrogen atom here, and I'm going to draw the structure of the other one as well. Okay, so they will be sharing this electron with each other in order to complete their outermost shell. So we have hydrogen here and we have hydrogen here. Okay, and this is the electron which is being shared between the two hydrogen atoms. So this sharing of electron between the two atoms is called as the covalent bonding. Okay, and you see the center of an atom is containing the nucleus, right? We all know that in the center of an atom there's a nucleus. So this basically is a force of attraction between the shared pair of electrons and the nucleus of an atom, right? Electron pair is negatively charged, right? It is having a negative charge, whereas the nucleus is positively charged. So this is a very strong force of attraction which is holding the atoms together, right? And this is called as the covalent bonding, right? So whenever you see any diagram or any bond, you should understand this bond is basically composed of two electrons, a dot and a cross, right? So this is the shared pair of electron between the two atoms, right? So in the covalent bonding, unlike the ionic bonding, there is no charged particle being formed and groups of atoms are chemically combined to form the molecules. So in the formation of covalent bond, each atom has an electron in the valence shell. As I've just explained, the electron shells of both atoms, they overlap, so that electron pair is produced and shared by both atoms. So in this way we get a single covalent bond between the two atoms. But there are multiple cases that you will see where you will be experiencing the double covalent bond and a triple covalent bond, which corresponds to sharing two pairs of electrons, and this corresponds to sharing three pair of electrons, which is equivalent to 6 electrons and 4 electrons respectively. The compounds which contain covalent bonding, they are called as the covalent compounds, and we divide our covalent compounds into different categories, right? So they are basically divided into two major categories. One is simple molecules, right? These are the simple structures, usually diatomic and triatomic in nature. And the other ones are giant covalent structures, which include diamond, graphite, and sand, silicon oxide, right? So let's first of all focus on the simple covalent molecules. What are simple covalent molecules? So simple covalent molecules are further divided into two main categories. One are called as the simple molecules and the other ones are called as One are called as simple molecules, and simple molecules are further divided into homoatomic and heteroatomic molecules. So homoatomic molecules are made up of same types of atoms, like we have hydrogen, fluorine, oxygen, nitrogen, chlorine, bromine, and iodine. So you will notice that all these molecules are made up of same types of atoms, right? Let's have a look at the very first atom, hydrogen, a molecule of hydrogen. So a molecule of hydrogen is made up of two atoms of hydrogen. So in exam, you will be required to draw the dot and cross diagram for the hydrogen molecule, right? So first thing you need to do is split your hydrogen molecule into the atoms. Let's say we have two atoms of hydrogen present in this molecule. Okay, so write down the number of electrons present in each atom and draw its structure. Okay, so let's say each hydrogen atom is having one electron. So we'll be having hydrogen with a one electron here. And we have another hydrogen atom. Make sure you represent one with the dot, another with the cross, right? So when they share their electrons together, you'll be getting a molecule of hydrogen, and both of the atoms will be having stable noble gas configuration, because the first shell can have maximum of 2 electrons. Remember that this shared pair of electron is shared by this atom as well as by this atom. So you need to count the number of electrons at the end. Let's say for this hydrogen atom we have 2 electrons, and for this hydrogen atom we have 2 electrons. It means that both are stable and both are following the stable noble gas configuration. Let's take a look at the second example. We have fluorine here. So in this molecule of fluorine, you will see that each fluorine is made up of is containing 9 electrons in total, right? You can take this from the periodic table that fluorine has atomic number of 9. So first thing you need to do is write down the electronic configuration of fluorine. So you will notice that the first shell will be having 2 and second will be having 7 electrons, right? And same goes for this 2 and 7. In most of the cases, you will be required to share the outer shell electrons only, but here I'm going to explain that you need to draw both the shells, right? So we have fluorine here with the first shell having 2 electrons and with the second shell having 7 electrons in total, right? 1, 2, 3, 4, 5, 6, 7. And you know that the outer shell must have 8 electrons to attain the noble gas configuration, right? It means how many electrons do we need to add in 7 to get 8? How many electrons does it require? Of course, 1 electron. So fluorine is going to share 1 electron with a neighboring fluorine atom. Okay, let's say we have another fluorine atom here. We have fluorine with the first shell having 2 electrons with the cross, and the second one will be having the 7 electrons. 1, 2, 3, 4, 5, 6, 7. And when they share their electrons together, you will be getting a structure like this. Okay, so this right there is the shared pair of electron between the fluorine atoms. So fluorine is sharing 1 electron, so you can also represent fluorine like this with the bond, single bond, right? And each bond in fluorine atom is basically a dot and a cross, right? And rest are all the lone pairs. Now one thing we need to understand that the shared pair is called as the bonding electrons, we call it bonding ones, and the unshared pair of electrons, this is called as the non-bonding electrons, okay? So because they are not involved in bonding process, they're like non-bonding electrons. Right, let's try chlorine here, and you need to show only the outer shell electrons for the chlorine. You can pause the video and try this question by yourself. Chlorine is 17 and 17 in total. It's made up of like 2 atoms of chlorine. So first shell can have 2, second can have 8, and last one is having 7 electrons. Now from here you will notice that since it is having 7 electrons in the outermost shell, it will be sharing 1 electron. Okay, so I'm going to draw the outer shell here for the chlorine atom. So the first shell can have maximum, okay, the last one, let's say last one. So we'll having 7 electrons, 1, 2, 3, 4, 5, 6, and 7. 1 I'm going to draw here inside, right? Because I need to show a shared pair. And we have another chlorine atom, and this one is for the other chlorine atom. So we'll be having 1, 2, 3, 4, 5, 6, and 7 electrons, right? So this is chlorine molecule. In some cases, you will see the atoms which are sharing more than 1 pair of electrons, right? So they will be sharing 2, 3, etc., and they will be forming different covalent bonds. Let's say oxygen. So oxygen is having 8 electrons, right? So the first shell can have maximum 2, second will be having maximum 6, 2 and 6. So how many electrons will oxygen share to complete its outermost shell? What do you think? Yes, it will share 2 electrons to complete its outermost shell. So let's draw the oxygen atom. We have oxygen here, and I'm going to show the outer shell electrons only, right? And this right there is the outermost shell of the oxygen. And since it is sharing 2 electrons, I'm going to draw 2 electrons over here, and rest I'm going to draw over here. 1, 2, 3, and 4. Total of 6 electrons, right? As you can see, 6. So make sure you draw 6 electrons. 2, 4, and 2, 6, right? So let's draw the other oxygen atom here. So we have another oxygen atom, and all these are the shared electrons. 1, 2, 3, 4, 5, and 6, right? So this right there is a structure of oxygen molecule. So you see how many bonding pair of electrons are there? Bonding pair, these are the bonding pair of electrons. You will see like 2 pairs. So since 2 pairs of electrons, it means oxygen can form double covalent bond between the other with the neighboring oxygen atom, right? So double covalent bond, right? So, and these are the non-bonding electron pairs, as you can see. So they are not involved in bonding process. So each oxygen atom over here in this molecule is having 2 lone pairs, 1 and 2. So the non-bonding electrons. Okay, let's try nitrogen atom, right? We have N2 here. Let's try this nitrogen, right? So first thing is you break your molecule into constituent atoms. So we have nitrogen here, it has 7 electrons in total, right? So the first shell having 2, and the last one is having 5 electrons, 2 and 5. So what do you think? How many electrons will it share to complete its octet? 3. Okay, so it means it's sharing, each nitrogen atom will be sharing 3 electrons to complete its octet. So let's draw nitrogen atom here. We have the first shell. Let's show electrons the outermost shell. Okay, so we have nitrogen with the outermost shell, right? and 1, 2. So it's sharing 3 electrons to complete its outermost shell. Remember, the number of electrons which are required to make 8, those will be the number of electrons which you need to share. Okay, so let's say it needs 3 more electrons to make 8, so it will be sharing like 3, 1, 2 and 3. So we have another nitrogen atom, and this nitrogen atom will be having 5 electrons. Okay, 1, 2, 3, 4, 5. Okay, so nitrogen, so this is going to be a triple covalent bond, like 3 pair of electrons are being shared, 1, 2 and 3. So triple covalent bond between the nitrogen atom. Okay, and you can express these lone pairs like this. Okay, so these are the non-bonding pair of electrons, and this right there is a dot and cross diagram for the nitrogen atom. Right, now let's try some of the questions from the heteroatomic molecules. Okay, so the heteroatomic molecules are basically made up of different types of atoms, so we call them heteroatomic molecules. Okay, so here we have some list of heteroatomic molecules which you need to focus on. So the first one is going to be the HCl, methane, ammonia, right? You can take an example of water, etc. right? So let's try the first molecule, which is HCl, a hydrochloric acid. So first thing you need to do, you need to break down this compound into its constituent elements. We have hydrogen and chlorine, 1, and chlorine is 17, sorry. So you need to share the outer shell electrons only. So let's draw. For hydrogen, we are only having 1 electron, and for chlorine, we're having 2, 8, and 7, right? So how do we draw? How many electrons are need to be shared between these two atoms so that both will be having the completely filled outermost shell or stable noble gas electronic configuration? Yep, they'll be sharing 1 electron. So if they share 1 electron, chlorine will be having 8, and hydrogen will be having 2, sorry, in the outermost shell, right? So let's draw. I'm going to draw chlorine here, right? So 7 electrons, 1, 2, 3, 4, 5, 6, and 7. Since 1 need to be shared, I have drawn 1 inside, right? And we have hydrogen here, so we have hydrogen, 1 electron for the hydrogen, HCl. Okay, so let's try this molecule by yourself. You can pause the video and try this question. Okay, so if you break it down, that will be carbon, 6, and 4 atoms of hydrogen, 4 different atoms of hydrogen with 1 electron each. So we have carbon here. Remember, it's a quick trick to draw the structures quickly. Always try to start your question with a central atom. This right there is a central atom. The central atom is the one which is alone. Okay, so 1, and we have 4 hydrogen atoms. This is going to be in the center, carbon. Okay, so start with the carbons. First shell is having 2, second is having 4, right? So I'm going to draw carbon here. Let's draw a little below over here. So we have carbon, and we have these different electrons. Since carbon is having 4 electrons, so it needs to share 4 more electrons to have completely filled outer shell with the 8 electrons, right? So let's draw carbon. So 1, 2, 3, 4, and we have 4 hydrogen atoms. So I'm going to draw 4 hydrogen atoms here. Hydrogen, 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 and hydrogen, right? So hydrogen are to be represented with a cross, and cross. Methane. Let's try this molecule, ammonia. First thing, break it down, nitrogen and hydrogen, right? Nitrogen is having 7 electrons, hydrogen is having 1 electron. Okay, so nitrogen is having electronic configuration 2 and 5, and hydrogen is having electronic configuration of 1, and you will see that there are 3 hydrogen atoms. Okay, so 3 hydrogen atoms which are having 1 electron. Okay, so how do you draw? Let's say outer shell, you need to show the outer shell electrons only. So we have nitrogen here with the 5 electrons in total, and it will be sharing 3 electrons. So I'm going to draw 3 electrons inside. Okay, 1, 2, and 3, and 2 can be drawn over here. So 3 hydrogens. So we have 1 hydrogen here, we have the second one here, and we have the third one here. Okay, so we have 3 different hydrogen atoms with the cross. Okay, so I know you're way better than me in drawing circles. I'm not good at drawing circles. Okay, so we have ammonia molecule here, right? So in some cases we are having some other examples. Let's say water here, H2O, right? So look for the central atom and try to draw that first. So we have oxygen in the center, right? So oxygen is 8 and 16. It means it's having like 8 electrons, and hydrogen is having only 1 electron. So write down electronic structure, 2 and 6, and hydrogen is having 1, right? So I'm going to draw oxygen with the 6 electrons over here. Okay, so oxygen with the 6 electrons. How many electrons will oxygen atom share to complete its octet? Yes, 2 electrons. So I'm going to draw here 1, 2, 3, 4, 5 and 6. Oxygen. 2 hydrogen atoms from the structure. I can see the 2 hydrogen atoms. I'm going to put 2 hydrogen atoms over here. So we have hydrogen with a cross and we have hydrogen with a cross, right? Now these are some examples, and there are like multiple other examples, so you can try all these questions by yourself, because I want to keep the video as short as possible so you can watch it completely, right? So try these 2 questions by yourself as a homework, right? And let's now look at some of the properties of covalent compounds. Okay, so like properties of covalent compounds. Okay, so covalent compounds, basically the first property you need to understand is that the covalent compounds I'm going to focus as simple molecules, right? So simple, I'm talking about the properties of simple molecules over here, right? Okay, so the first property is that they have low melting and boiling points. Right? In exam, you will be required to give a reason for the statement that why do they have low melting and boiling points. A very simple and generic statement. You should remember that they contain weak intermolecular forces of attractions. Right? They are held together by weak intermolecular forces of attractions. Okay, the specific word we call them van der Waals forces. Okay. Right. So let's take an example. Right, we have carbon dioxide, for example. Right, so the neighboring carbon dioxide molecule will be having attraction, right? So, but these forces of attractions are very, very weaker, right? They're like very weak. Okay, so they will be having very low melting and boiling point. You can take an example of water here, right? Water is having hydrogen bonding with the neighboring atoms of other water molecule, right? But still, these forces of attractions are weaker, and when I call them weaker, it means I am comparing them with the ionic compounds. Okay, so they are weaker as compared to the ionic compounds. Second property you need to focus, that is electrical conductivity. What do you think? Electrical conductivity. So they are poor conductors. Okay, so poor conductors. They are not good electrical conductors. Why? Reason: no free ions or electrons available. They do not have any kind of free ions, no charged particle or electrons, okay, available to carry electric current. Okay. The third property, most of these compounds you will see, talking about the simple molecules, they are liquids and gases at room temperature. Right? Why? What is the reason? Weak intermolecular forces. This is the most generic term that you'll be using again and again in your responses, that they have weak intermolecular forces, but the covalent bonds are very strong. You cannot break the covalent bond. Right? So if you have, let's say, two water molecules which are very close to each other, right? So they will be having this bonding, which is weaker intermolecular force or hydrogen bonding. Okay, if we call it more specifically. But this right there is the covalent bond, right? This is covalent bond, very strong. But this one is weak because it is intermolecular force between two different molecules. So weak, but this is strong. So this determines the properties. I'm talking about the properties on the basis of the intermolecular forces. Right, so this is all about the covalent bonding, and let's try some of the past exam questions from here. You will see in the past papers. Describe the term covalent bond. What is covalent bond? Yes, it is shared pair of electron. Yep. Between two nonmetals, or you can say shared pair or force of attraction between the nuclei of two atoms nuclei of 2 atoms, right? And the shared pair, right? Shared pair of electrons, okay? Here we have a diagram. If you just read the question, complete a dot and cross diagram for the molecule. Since you see that this iodine molecule is being shown in the diagram, and chlorine, bromine, and iodine are in group number 7. So you need to show the outer shell electrons. And we know the rule that whatever is the number of the group, that will be the number of the outer shell electrons. So both of these atoms will be having 7 electrons in the outermost shell. Okay, we're having like 7 electrons, okay? So we have 1, 2, 3, 4, 5, 6, and 1 I'm going to draw here, 7. 1, 2, 3, 4, 5, 6, and 7. Okay, pause the video and try this question by yourself. For ammonia, you see nitrogen is having atomic number of 7 and hydrogen is having atomic number of 1. So nitrogen belongs to group 7, so 2 and 5, 1. So I'm going to draw 5 electrons for nitrogen, 1, 2, 3, 4, 5. And now I need to draw for hydrogen, 1, 2, and 3. So ammonia. Carbon dioxide. So how do you draw the structure of carbon dioxide? So try this question by yourself, and like, share, and subscribe this channel for more informative videos and for better exam prep. Thank you so much.